Right, so I think we can go ahead and get started. Just give me 1 minute to make sure I have access to everything here. Mhm. All right. I think we should be good. All right, so let's go ahead and get started. Hi, everyone. Welcome to Python Fundamentals assignment review session week 2. My name is Siavash. I'll be the instructor for this session. So the format of this class is pretty much the same as last week. Hopefully you got the chance to take a look at these problems, try them out. What we're going to do is we're going to first go over some multiple choice questions, and which is kind of a review on what we learned in the class. That should be like 20-25 minutes. And then after that, we're going to start going over the coding part. Coding part would be exactly the same format. It's a leap code type of problem. We're gonna type in our solutions, and then we're gonna check the answers. And if the time permits, I'm gonna give you even more solutions. If not, I'm gonna share the notebook with you for the solutions, and you can take a look later. So one more thing is that the solutions we are providing to these questions is not supposed to be optimized. Some of the solutions that I mentioned turn out to be the optimized solution, but that's not the purpose here. I just want to show you how we can use the tools and the definitions we learned in Python to solve these problems in Python. The last thing is there's no TA for this class, so I'm going to make sure I pause and I address if there are any questions, please put them in the Q&A or chat. Both are fine. And if there is a need for further clarification, let me know. Please raise your hand, and after I'm done with the answer to the questions, I will go over yours. Okay, so I think we can now get started with the multiple choice questions. We have a few of them. All right, so the first question is, what will be the output for this code? So we are given a string on the first line. We know that this is a string because our object or our sequence of characters are enclosed between double quotes. We know that strings, this is how we define a string, with quotes, double quotes, or triple quotes. And then we are printing a subset of those characters on the second line. So this is called slicing. So we know we can get a subset of these characters. And this is also the case for other data types in Python. We can do this for example, lists or tuples, where we actually have indexes for the items. So here we are looking at nothing provided before the column, and then this number. We know that if you provide nothing for the beginning index, we start from 0 or the beginning of a sequence. So it starts from 0, and then we know that the ending index is exclusive. So we start from here. We go 0, 1, 2, 3, 4. So basically that will be what is going to be printed out in the display. Okay, so option 1 would be the right choice. So one more thing here is we have dropped the step size. If you put another colon at the end and then another number, that would give us the step size. Okay, so we can skip some characters on the way. Okay, just to make sure there are no questions here. So let's go to the next one. So the question is, select the correct output of the following string options or operations. We are given this string, and we are given a substring. So this substring is, or is, you see that it has replicated multiple times in our original string. And the question is, what is the display output for this print operation here? So we have the string one dot count, the substring that we are given on this line, and there's a number 4 after that. So we learned about the count function in class. So we learned that you can use it for strings, for lists, or tuples to count a number of items. We know that if there's no 4 here, then we would count all these is substrings here, right? But when there's a 4, then this gives us a starting index, right? So when there's a 4 inside count, it's pointing to the 4th index in the string, starting from here, 0, 1, 2, 3, 4. So if we start from here, then we have to drop the first substring, right? Because we have already passed I. So if we pass that, then we have 1, 2, 3 here, and then we have 4, 5, 6 here. So we count this substring, it's 6, if we start from index 4. Okay. So the right answer is option 2. Any questions? All right, so let's go to the next one. What will be the output of this code? So we are given a function. So there's no type hinting here, so we don't know. By a quick look, we cannot really say what's the type of the input data and what is the type of the return data. But when you look into it more closely, you see that there's a concatenation happening on the first line of the function with a character. And this is a digit, but it's actually enclosed in single quotes, which makes it a character. So this first line is a concatenation, then we can assume that A is a string or another character. Then we have this multiplication between the two, multiplication operator or the star operator, which we know that for strings becomes another basically concatenation, but concatenation with itself, right? So we are concatenating A with A 2 times. So if this was 3, we would concatenate it 3 times. So this is what happens here, and then we return that string. So we are asked to predict what is the output of this print. So we have this function, it's calling this string here. And if we plug in this string inside this function, first we are concatenating it with 2 as character. So it makes it hello 2, right, after this first line. And then here we are duplicating that. So it becomes 2 times hello 2, right? So hello concatenate with 2, another hello, another 2. Okay, so that's what we get in the output here. So the right answer is option 4. So it says on this option cannot perform mathematical operation, but that's not the case because this one is enclosed in quotes, right? So the first option says indentation error. That's not the case because we are actually following the indentation rule inside our function block. Okay, so I see there's a question that there's a request that I go over question 2 again. Let me actually go over that. So we learned in the class that we have this method for all the sequence or indexed based data types that we learned, which are lists, strings, and tuples. We can actually count number of items. So here's our original string, and then we're going to count this substring inside that string, right? So if there is no 4, then we simply look for all these is characters repeated after the other. So we have 1, we have 2, 3, 4, 5, 6, 7, right? So this number 4 is basically saying that start your search from the 4th index. So we're going to start from this index. Okay, so this is now our truncated string that we're going to look into to search for this number of, how many of these substring that we have. So starting from here, we lose one of those is substrings, right? So if it was 7, now it will be 6. Okay, so hopefully it makes sense now. Any other questions about these three problems so far? Right, so if there are no questions, let's go to the next one. So the next question is, what data type is the object below? So we are given this object. So we can actually answer to this right off the bat when we see we have square brackets, right? So among all these data structures that we learned so far, we know that there's only lists that start and end with square brackets. So that would make it easy. But there are a couple other things. We see a duplicate here. It's usually there's no issue with defining a set with duplicates, but we know that sets do not allow duplicates. So if there was curly brackets here, and this would become a set, but then we would not allow duplicates as well. It could never be a dictionary, because dictionaries are the structure of a dictionary is based on key value pairs, but here we only see keys, right? And the last thing is, this is not a tuple because we have square brackets. If these were open and closed parentheses, then this would become a tuple. The right answer would be option 1. This is a Python list. All right, cool. So let's get to next one. What is the output of this code? All right, so let's go line by line. So the first line, we are defining a set. The reason I know it's a set, again, same as the previous problem, we have curly braces and we only have keys, no values. If there were values, then we would have a dictionary. But here we have a set and we assign it to a variable named set1. On the second line, we have another set and we assign it to set3. On the third line, we are actually assigning something to set3, but this something here, this object is actually a dictionary, right? So we learned in the class that if you have empty curly braces, then this is actually an empty dictionary. It's not an empty set. If you want to create an empty set, you have to use the set constructor, which was the actual English word set with open and close parentheses. So this line is going to give us a dictionary. But do we even need that? On the next line, we are finding the intersection of set1 and set2. This is the operation for intersection, if you remember. And we are assigning that on set3 again. So basically what we define here, what we initiate here, we are overwriting on the fourth line. So although this was an empty dictionary, now we are overriding that with another set. And this set is the intersection of these two sets. And the intersection of those two sets is number 3, right? Which we're going to print here. So the final answer is we're going to have a set which has only one element, and that is 3. Okay. Any questions on this one? Abhinav, please go ahead.
Why would set 3 equals to set 1 and set 2 not throw an error? It should throw some sort of a compilation or some.
Why should it throw error? Because it's now changing from dictionary to a set.
Yes, that's my question. Yes, it is defined as a dictionary, and then we are concatenating two sets into the same object.
So
So
if you remember, please continue.
no. That I think you got the question. So
Yeah, I got the question. And if you remember, from I think it was the first few slides on the first class, which we mentioned, Python is a dynamic typing language, right? So that's why you don't really put a set or dictionary before defining a variable, like what you do in other languages. You put an int or double something, right? So that's why when you define some variable, you can actually use the same variable name with another data type, as long as you overwrite it, like what we are doing in these lines, right? So if you remember on the notebook on the first week, if you double check that, we had an exercise in the class that we started with some integer. I think I called it A or something. And then from the integer, we went to a string. From there, we went to a Boolean. And there was no error. At each point, we would get the updated value. So this is allowed in Python.
Right. Thank you. So just one more quick follow-up. If this was not an empty dictionary, because it's a complex object, if I had initiated it with some values, etc., even then this would have thrown any error, correct?
Yes.
It would have just on the fly the change, just like it.
Exactly. It could be anything. This could be any other value, but still you could overwrite it.
Thank you, Siavash.
Yeah, of course. Any other questions? All right. Let's get to the next one. So the next question is, if A is a dictionary with some key value pairs, what does a.pop item do? So you remember from the class, I mean, if you remember from the class, if not, please go back to the slides. We had three different ways to remove items from a dictionary. One was pop, which would pop a dictionary based on a given key. And the thing about .pop was it would return the value of that key, right? And then we had .pop item, which would remove the most recently added item to the dictionary. And that was, that was the reason we would say a dictionary is ordered in Python, because the order of insertion of key and value elements matters, right? Because if you want to use pop item, it would basically remove the last added key value pair. And then there was another way to do that using delete or del keyword, which would delete the pair without returning anything, right? But you would need to pass on the key for that. So now looking at the options for pop item, we are looking at option 3, which is to remove the last added key value pair. Okay. So that will be the right option. So the last option removes the key value pair for the given key is actually pop. It could also be delete. It should say whether that will return something. If it will return, it would be pop. But the right answer for pop item is definitely option 3. All right, so and the last one is actually an interesting question. So the last question is, we are given two lists, list 1 and list 2. So the question is, select all the correct options to join two lists in Python into a new list, right? So what are different ways that we can join these two into one single list in Python. But we actually want to get a new list, right? So basically, we're not looking for an in-place operation. So I think we discussed this in the class to some extent. I think there was a question in this week's class that, what is the difference between concatenation of the lists and dot extend for lists? So actually, I want to ask to see if anyone wants to tell us what they think about which of these options are the correct option. There could be more than one answer, or could it be only one? Any ideas? So let's see. Sudhakar, you want to go ahead?
I think it's one only, because all the other options are going the path of extend. So you won't get a new list in that scenario.
Yeah, so shall we go one by one? Because each option has its own story, basically. So option one, so basically you're saying that option one is giving us a new list by joining all these items, right?
Yes.
Yeah, then that's correct, because we are concatenating two lists and it's going to give us a new list. So basically concatenation returns a list, which is what we're looking for. How about the second choice?
It kind of extends the list one, but that is not what they're asking, because they want the end result to be a new list.
So now my question is this even a correct syntax?
Wow. I didn't think along those lines, sorry.
Yeah, no worries. But so because we learned extend in a very particular context and how we can use it, right? And that's the only way we can use extend. Now, my question is, out of these three choices, which one is the right syntax, and why it cannot be among the answers? I think
I
you
think
answered
only three has a valid syntax. The other 2 and 4 are gone, are eliminated from that perspective.
Yeah, exactly. That's correct. But then what happens here on this line 3? So we have list one.extend and then list 2. This is the right syntax.
But it
right?
doesn't result into a new list. It'll, I don't know how to call it, but I think the existing list is your end result. So because of that
Yes.
parenthesis requirement of new list, 3 gets eliminated.
Yeah. I think that's perfectly that's totally correct. So the only thing is that this new list will become a null, right? So it will become a non-value, because this operation is in place and it will not return any value. If you assign it to some new variable, it will assign none to that variable. So what basically happens on this line is that we extend list one in place with list two, right? So list one actually changes to these 4 letters and then the rest of these letters from list two.
Okay.
And that's pretty much it. And new becomes none.
Oh, list one changes, but new list doesn't get that assignment at all.
Exactly.
Okay,
Yeah.
got it. Thanks.
Yeah. Thank you. All right, and then okay, so we know what list one does, what option one does. We know what option 3 does. Option 2 is not correct syntax wise, because extend, there's no function in Python named extend unless you define your own function so that you can actually use extend, which needs to have 2 arguments, and then you can use it this way, and then you have to return a value to get this new list. And option 4 is not correct, because to extend the list, you actually need to provide the name of that list first and then dot extend with the second list. Here we have new list, which is not defined in our code. So this would give you an error if you don't define new list. But then there's another issue here. You cannot have two arguments for extend. You only should have only one list as the argument to extend. Okay. So any questions on this one or any other multiple choice problems that we had? So I think there was oh, there's no question actually. This is the answer. Any questions? I see there's a hand raised. Vijita?
So if let's say and we just did a option 3. I'm going to discuss about option 3. If we did a separate, if there were two lines of code, list 1 dot extend and list 2 in bracket, that was one line, and if we did a new line and it said new list is equal to list 1, then
Yep.
the list would have the
Yes.
join. Okay.
Yes, that's correct. That's correct, because you're now copying all the value. By its reference, you're actually copying all the value of list 1 into new list, right? In that case, new list becomes actually list 1. So yeah, you'll see that change in new list. That's correct.
Okay.
Yeah. Cool. Any other questions? Right. So if there are no more questions, let's go back here and let's begin with the first coding problem. All right. Make sure I'm looking at the right notebook on the other page. Okay, so the first question is to sum in a sorted array. So given an array sorted in non-decreasing order and a target number, find the indices of the two values from the array that sum up to the given target. Okay, so for example, this is the given list, right? And then we are given also a target. So we're going to find the indexes that sum up to this number here. Okay. So for example, here we have 2 and 5, which sum up to 7. So 2 and 5, what are the indexes? It's 0, 1, and 2, 3, right? So 1 and 3 are the indexes for those two elements. So we have some notes here. In case no answer exists, return an array of size 2 with both values equal to -1. In case multiple answer exists, you may return any of them. The order of the indices that are returned does not matter. A single index cannot be used twice. So for example, if this was a 6, the target was 6, we cannot actually have 3 and 3 as the answer. So we cannot have one single element repeated twice for the final answer. Okay. So does the question make sense? Okay. So for this one, actually, we are going to cover 2 different ways. So one is usually the way we do it is the brute force solution. So I'm going to write solution 1 brute force, and for solution 2 we have 2 pointers. Okay, so I'm gonna show you 2 different ways to solve this one. So in the first solution, we're not going to use the fact that this array is sorted, right? So the question is saying we have a sorted array. But in the first solution, we're just going to have some solution that works. And for the second solution, which is going to be a more efficient way of doing it, we are going to use the fact that this array is actually sorted. Okay. So one thing I wanted to mention before I begin with the solution is usually in the interviews, if you're actually faced such a problem and it's not easy for you to come up with the most optimized solution, at first, then it would be very helpful if you can actually go with the brute force solution to show that you know actually what's going on, what's the input, what's the output, and then over the next few minutes after you provide the first one, then you can have actually some discussion with the interviewer and then come up with a more optimized way to solve this problem. So it's always good to have an idea of how the brute force will look like. Okay, so what I'm going to do, so let's actually copy the list here. And what is the target? Our target is 7, right? So this is the numbers. What I'm going to do is I'm going to define 2 indexes here. And both of the indexes for now, let's say they're referring to 2 consecutive elements, right? So one is here and the other one here. So I'm going to iterate through, while fixing I, I'm going to iterate by j through the rest of the elements. And as soon as I get 2 numbers which sum up to 7, I'm going to pause. I'm going to return those indexes. If I go to the end by j and I cannot find it, then what I would do, I would take I to the next item, and then j starts from the one after that, right? So it goes all the way to the end. If I cannot find, then I moves, right? So one of them is basically the support. It would stay, and then the other one would try to search the complement of that number, right? And in this case, when j is at 5, I is at 2, we're going to get the answer. Okay, and I and j would be the indexes we were going to return. Okay, so let's actually implement that. We'll have for I in range length of numbers, right? So we have, you remember from previous classes that length gives us the function, is the function which gives us the length of numbers. In this case would be 5. And range is the function which gives us a range. Starting from 0 to 5 will be 0, 1, 2, 3, 4, right? So that will be our I. And then now we need another for loop to basically do the iteration for the second index, right? So we have for j in range. Now here, we have the option to either go from the beginning, right? But we don't need that because I already has seen that. So we can start j from the next element after I, right? So we can start from I plus 1. I plus 1. And then we can go all the way to the end of that array, right? So we can go all the way to the end. Okay. So we have two of these pointers. One is moving, one is fixed, and one is moving. And then if we cannot find those 2 indexes, one moves again. The first one moves again, and then we continue the search. Now, if the sum of these 2 becomes that target, which we define right here, then we're good to return those values. So if numbers at I plus numbers at j, the value is equal to target, right? Then we're going to return I and j. Okay. So if this sum at this point is going to give us that target, we're going to return those indexes. But if we are out of this whole nested for loop iteration, if we cannot find that, what we're looking for, we're going to return -1, -1. Okay. So this is called the brute force solution because we basically check every pair of possible solutions, and then as soon as we find the one, we're going to stop. So there's a question that why are we not doing length of the numbers -1? The answer is that when we put length of numbers, it goes 1 to the last, right? So here we have 5. If you put 5, it starts from 0 and goes all the way to 4. So when I put len here, it means it goes all the way to 4, not 5. So if you want all the elements to be covered, you can do that. So I think your questions also stems from the fact that here I doesn't have to go to the end, right? If that's why you're saying that, you're right. You can also do a -1 here too, because I goes all the way to 1 to the end, and J checks that, and then we're good to go. But even if I goes to the end, we're also fine, because if I goes to the end, then this for loop will not even proceed, right? So yeah, both should work fine. All right, any other questions? All right, so if there are no questions, let me now show you how to solve this with a two-pointer approach. So for the two-pointer approach, we're going to begin from both ends. So let's say we have, if you remember, we had a two-pointer solution previous week. I think we had 2 questions with that idea. So we start from left and right. Now, each time that our indexes are pointing to an element, we're going to check the sum, right? And then if the sum is greater than this target, it means that we have to bring it down. If the sum is less than the target, we have to bring it up, right? Now, how are we guaranteed that we are actually getting closer to target? The reason is that our array is sorted. So because it's sorted, if R goes to the left, our sum will go down. And if L goes to the right, our sum will go up, right? So that's basically the idea here. So we're going to move this L and R all the way to the left and right until we get to that sum. If for any reason we cannot find it, then L and R meet at some point, and that is the point that we get out of our search or out of our loop, and we return -1s. Okay, so this is the idea here. So in this case, L, R, they're pointing to 1 and 10. The sum is 11. 11 is greater than 7, so R has to go to the left. Now 1 and 5 is 6. It's less than target, so L has to go to the right. Now L and R are actually pointing to 7. Their sum is pointing to 7, so that's our answer. So we are gonna return L and R. Okay. All right, so let me some space here. Okay, so let's see how we can write the code. So I'm going to actually define L and R to be 0 and length of numbers -1. So here I put numbers -1 because I want it to be the exact index. This is not a range, so I want it to be the exact index. So L is 0, R is len of numbers -1. Now I'm going to define a for loop and a while loop and go through this loop while left is less than R. And then the first thing I'm going to do is I'm going to check the sum at that point. Let's call it current sum. So the reason I put a current is because sum is a keyword, right? So I don't want to use that keyword here. So the current sum is numbers at L plus numbers at R, right? So the first thing we do we get the sum. Now we are going to check to see where does sum, basically lands before or after target on our line of real numbers, right? So let's say if the current sum is less than target, right? So what happens then is we need to bring L1 to the right? So we take L and increment it by 1. Else, if the current sum is greater than target, right? So if it's the value of our current sum is greater than target, we are going to move right 1 to the left, right? So the right index goes 1 to the left. And then what is the other option? So if the current sum is not less than target, if it's not greater than target, the last option that remains is they're equal, right? So else, if they're equal, it means that we hit the target. So we're done. So we have to return left and right. Okay. So this while loop would continue until we find these two indexes, or we would never find it and L and R meet at some point, which means we violate this condition here. So we get out of this while loop, and our only chance is to just return -1 and -1 to wrap this up. Okay, so that's our second solution. Now, this is overall a better solution because we are passing through this list only once, right? So we have 2 pointers, and together they're passing this list once. But in our first solution, we have a nested for loop, and you remember that we said try to avoid nested for loops as far as you can. And here we are passing through elements multiple times without really needing to, right? So yeah. So there's a comment that this could also be while L less than or equal R. So if we put L less than or equal R, then this will be not correct, if I understand correctly, because if we allow L to be equal to R, then let's say we have our target is 6, and we couldn't find the target. So let's say this is not 1, or let's say this is 7, right? So what happens here is we get all the way to the case that L and R are referring to this 3. Okay. So if that's the case, then this condition, this has happened, right? So this will happen, and then we'll get in return L and R, which are both 3, right? But that is not true because, that is not correct, because here it says a single index cannot be used twice. So specifically, if this is less than or equal, I believe this is not the right solution. Okay. But that was a great point. Thanks for bringing that up. So the other comment is, if the list is not sorted, will it be possible to solve with 2 pointers method? So if the list is not sorted, I cannot think of any way to solve it with 2 pointers. But actually, if the list is not sorted, we can solve this problem with a dictionary. And I highly encourage everyone to think about that problem on your own and see how you can solve this problem with a dictionary. So that is actually not I would say this, if you look at LeetCode, they have some rankings of easy, medium, hard. So I would say this solution is an easy solution. This is easy, medium, and that dictionary solution becomes medium and a little bit more challenging, right? Yeah. So see if you can solve this. The question without being sorted with a dictionary. So see if you can solve that. Any questions on this problem? So let's go to the next one. All right. So the next question is the majority element. Find the majority element in a given list for a list of size n. The majority element is the element that appears more than floor of n over 2 times. So floor of a number means remove the decimals, right? The integer part of the number. And then the question is, given this list, just count the numbers. So how many threes we have? We have 4, and we have 3 2s, right? So how many values do we have here? We have 7 values. 7 over 2, it's 3.5. The floor of 3.5 is 3. So each element which has frequency above 3 would be the majority element. Okay. So you may ask, what if there's no majority element? The answer is, if you look at the notes, it says the majority element will always exist. So we can easily rule out the case that there's no majority element. And then it's also defining what's the floor of X, and we know what that is, right? So that's fine. All right, so for this one, I'm actually going to show you, again, I'm going to show you a brute force solution. Brute force. And then I'm going to show you another solution using dictionaries. There's a third solution, which is the more advanced solution, highly optimized, very efficient, but it's out of the scope here. And I'm actually going to put that in the notebook, which I'm going to share with you. Try to see if you can come up with some ideas, but it's very, I would say, a hard solution. So we have easy, medium. This one is hard. If you haven't seen the idea, it's very tough to get to that kind of idea on how to get to these kind of solutions. And that's perfectly fine, because there are not that many people who actually can think of such a solution in the first shot. So you see these kind of answers to these problems, and then you see these kind of patterns, and then you get more and more comfortable with these, kind of ideation for these problems. Okay, so the first solution is the brute force solution, and then what we're going to do, we're going to make it, we're going to just go with a very messy solution. So each time, so I'm going to go through all of these members in this list, and each time I see a number, I'm going to count that number in the list, and then I'm going to check if that count hits this boundary. If it does, I mean, it's above that. If it does, we're good. So we found the majority element. If it doesn't, then we go to the next element and we count it again. Okay, so I think you have already guessed why this is very inefficient, because each time we get to a number 3, we are counting it again. So do we really have to? No, not really. Okay, so let's do that first and then see how we can make it more optimized using a dictionary. All right. So let's say so I'm gonna start iterating through all these elements. So for num, in nums, what I'm gonna do is I'm gonna count that element. So if nums dot count of num, so you know that we have this dot count, we saw that earlier today, and we want to count this number inside this list, right? So if this count is greater than, so for floor, if you remember from the modules topic, that we have this math module, right? So math.floor would give us that floor. The other thing you could do, you could just typecast the number as an integer. So that would also give you the integer part. So both should work. Math.floor, and then you're going to see what are the number of elements divided by 2. So we have length of nums divided by 2, right? So if this condition holds, then what we're going to do is we're going to basically return that value, which has the majority element. So we're going to return num, right? And it's okay to leave the outside of the for loop blank, because we know that such element will always exist. Okay. All right, so this was our first solution. I would say this is highly inefficient. And the reason to that is each time we get to a number, we are counting it. So it's basically similar to a nested for loop, because each time you call this count, it's going to go through the whole list to count that element. So you are passing through this list once, and then each time you're passing through it again, twice. So we're basically inside a nested for loop, which actually these kind of solutions, if you run them, you could see that they may actually fail some of the test cases. And the reason is because they're highly inefficient. Okay, so any questions about the first solution before I go to the next one? Okay, so one last thing before I go to the next one. The other thing you can actually do here is to use length of numbers /2, because that was the integer, the floor division, right? So the integer division. So you could replace this with that. And if you're using math, you probably would also need to import math, but in this platform, you don't have to. It comes with all those basic Python libraries, so you don't really need to basically import those here. Okay, so the second solution is how to use dictionaries to get actually a record of all these elements and how many times they occur inside this list, right? So I'm going to start with a dictionary, which I'm going to call counts. So counts is an empty dictionary, right? Now I'm going to go through all these numbers only once, and each time I'm going to see if I have seen that before or not. If I haven't seen that, that means that will be a new key in my dictionary with a value of 1, which means the first time I'm seeing it. If it already exists in my dictionary, it will increment the value of that existing key by 1, which means, okay, so I'm seeing it another time, increment the value by 1. Okay. So let's do that. For num in nums, again, we go through all the numbers. Now, if num not in my dictionary, right? So if num does not exist in my dictionary, I'm going to introduce it to my dictionary. So I'm going to say counts of num is equal to 1. So this is the key in my dictionary, and this is the corresponding value. So this is the first time I see that, I add it here. Else, which means if num, that number already exists in the dictionary, I have something similar, but instead of introducing it, I'm going to increment the frequency, the count. Okay. So what happens after this line is basically now I have a dictionary which is counting these elements one by one, right? So when this for loop is finished, for this example, if I copy this example here, then when this for loop is finished, then I probably have some dictionary which looks like this. Counts is a dictionary which says 3 has 4 elements and 2 has 3 elements, right? But we don't need to wait for the dictionary to be formed completely. As soon as one of these values get to that threshold that we're looking for a majority element, we're good, right? So we don't need to wait for the other elements. So here, while we're creating this dictionary, we also add this check. So we would say if one of these values, so we counts at this key, which gives us the value corresponding to that key, is greater than same thing. The condition is this, right? If this holds, then we can return null, right? So we don't have to wait for the remaining elements of the dictionary because we already have a majority element and we're good, right? And yeah, that's pretty much it. So I think that's enough for this one because there's no case of non-existing majority element. So we don't need to basically add anything outside of this for loop. All right, so any questions on these two solutions? So there's a question that can we pick the max value, and if it's greater than this number here, we return that key. So you can do that for sure. So you can actually, what you can do is you form this dictionary completely, and then go one by one for each item. So you write a for loop, and then for each item, for each key value pair, if the value is greater than that number, then return the key, as you mentioned, right? But in that case, you need to form the full dictionary. Okay, so then that would be a bit inefficient because you could actually do that here on the spot, right? So you can just, as soon as you see that type of value, you can just cut it and return the value. So I see that you have a follow-up. I meant sort the dictionary by value in descending order. So you cannot sort the dictionary. Okay, so the dictionary is ordered, but you cannot really sort it. What you can do is that you can create a list of tuples of dictionaries key value pairs, and then sort that list based on the first element of those tuples. That's a good idea, but then if you think about, optimized code, going from dictionary to a list is costly, and then sorting would also be costly, but that is an option for sure. Can we use default dictionary that will eliminate the need for the if-else clause? The answer is yes. You can use a default dictionary, which would give you this by default. So I will encourage you to take a look at that. So that is out of scope. So take a look at default dictionary. So this is something you probably will learn in data structure and algorithms. So default dictionary comes with some characteristics. One of the important ones is you can actually define the default value, right? So if you create a dictionary using default dictionary, then it can actually, you can define it in a way that it starts with 1 already. So you don't have to check if it's not in count. So basically, but yeah, feel free to take a look, but this is above what we actually cover here. The other question is, the get function is really useful. Count with get +1. Yes. So there's an idea here that why can't we just put this into a line like this? So basically what happens is you get the value of the num, the corresponding value of num. But if there is no num, then it would go with the default value of 0. And then you always add it to 1, right? And this is actually a very nice trick because it will handle both cases nicely in one single line. So basically, you can actually put this as an option which could be written instead of these 4 lines. Okay. So yeah, great point. And thank you all for these great suggestions. Any other question? I see there's a hand raised. Abhinav, please go ahead.
Yeah, I wanted to ask the question about the line 38. In an interview setting, if we are using Python to write, and if this was, let's say, the optimized solution, would it get you any brownie points to actually write it this way? Basically using Python's ability to reduce the, like making it easier by reducing the lines of code, etc. Than
Yeah.
a more expanded, but a bit more intuitive for someone who may not, for whom Python may not be the first language.
Yeah, I understand your question. And the answer is it totally depends on your interviewer. And also the question they're asking, if this is the focus of the interview that they're trying to assess if we can write a code from scratch, then probably this is not a good idea. But mostly in most of the interviews that I've attended, this is perfectly fine because it's not usually the main focus of the interview. So they're good with you using anything which you might be helpful usually, but then they will let you know. So you can actually say, this is how I can do that. Then you ask them, is this okay? They will say, this is fine, but we also prefer that you write how you can actually implement this from scratch. And yeah, there will be a continuous conversation between you and the interviewer, and they will set the expectation for you in the interview. All right, so let's go now to the next question. All right. So the next question is, check if an array contains duplicates. Check if an array occurs more than once in a given list of numbers. Return true if an array contains duplicates, else return false. Okay, so if you have this array, we get a true returned because we have 2 number of 10s. So we have a duplicate, so it will return true. Here, there's all of them are unique numbers. We'll get a false. Okay. So we had this question in the class, if you remember, was one of our examples. And we can use sets because sets do not allow duplicates. And if you use a set on this example, then the length of that set would be lower than the length of the list, right? So the length of the set would be 3, the length of the list would be 4. So I'm not going to go over that solution again. We have already seen that. What I'm going to actually show you, I mean, if you're interested in the set solution, feel free to take a look at the notebook that I shared you. But what I'm going to share you is 2 different solutions. So together with those, we have 4 different solutions. So what I'm going to share with you is, first of all, a brute force solution, like always. And then the other one, I'm going to use sorting, which is not the best way, but it's still okay solution. It's good to see these ideas, but not always the best solution. In data structure and algorithms, you'll learn the best way to use these things. All right, so the first solution is brute force. What I'm going to do is I'm going to search through everything again, and then see if there are any duplicates. If there are, I'm going to return true. Otherwise, I'm going to return false. Should be pretty straightforward, right? So for I in range of length of nums, and then for j in range of starting from the next index next to I to the right, length of nums, right? So going I starting from the first index, j going all the way to the end. You cannot find any duplicates. I goes to the next, and j goes all the way to the end until I reaches the last item. So we have I, we have j. If nums at I is equal to nums at j, then we have a duplicate. We will return true. And if we are out of these two for loops, or this nested for loop, actually, we're going to return a false. Okay. So we have seen something similar in the first question today, but are there any questions? Does this make sense? Okay, so if no questions, then the next solution is if we can actually have these numbers sorted in any way, then instead of trying to remove duplicates or try to find duplicates from the entire list, what we can do is to go through this list once, and each time the current index is looking at its neighbor, right? Because now if there are any duplicates, they're going to sit beside each other because it's sorted. So at each point, the current index will look at the neighbor which goes to the right, so to the next index. If they're equal, then we will return true. If we go to the end of the list and we cannot find any duplicates, we will return false. Okay, so the very first thing I would do is I would sort this list in place, right? So next week we're going to learn about sort. We have two options. We have sorted.nums. In that case, you have to get new nums, a new returned value. But you can also put .sort to sort this object in place. So I'm going to use that for now, and then we'll see how sorted works next week. Now, I'm going to loop through this list of numbers again. But now I'm going to go all the way to 1 to the end, because at each step, I'm going to look at the element to the right. If I go all the way to the end, there's no element to my right at the end, and that's going to issue an error, right? So I put length of numbers -1. And then each time I'm going to check if nums at I is equal to nums at I plus 1, right? So I'm going to check to see what is the value of the element after me. If that's equal to the value at my index, I'm going to return true because I found a duplicate. Return true. If I'm out of this for loop and I'm not successful in finding any duplicates, then I'm going to return false. Okay. All good? Any questions? So there's a hand raised. Vijita, please go ahead.
So, in terms of complexity, I mean, sorting option is not so optimized, right? Compared to which one is a better optimized, or the length solution for the sets one, or checking after sorting, because sorting is again order of n log n, right?
Exactly. Yeah. So in terms of complexity from the solutions we we have seen so far. The second solution we provided in the class where we had this checker set. So you remember we had this check set, and you would go through this linearly. You pass through this list of numbers, and if your number was in that set, then you have a duplicate. If it wasn't, you will add it to the set. Because
Right.
it's a linear pass through this list, that would be the most efficient or the most optimal solution from time complexity viewpoint.
Okay.
Yeah. Cool. Thank you for the question. Any other questions? So there's a question that in the second solution, what happens if the list has only one element? Then what happens here is, so let's see if the constraints, any elements in the input list. Yeah, that's a great point, actually. So if there's only one element, then, okay, so what happens here is, so if you only have one element, the length of nums would be 1, right? The 1 minus 1 would be 0. And range of 0 would never go through, right? We always return false. So if you have for I in range 0, then it would just jumps out of this for loop. And we would return false. Okay, so automatically we realize that there's no duplicates here. But that was a great point. That's an important edge case that we have to take care of. I see there's a hand raised. Brian, please go ahead.
Hi, can you hear me?
Yes, I can hear you.
Oh, okay. It's odd. I have noticed in some of these interview questions, when something is n squared or n log n, quite often that the complexity can be reduced by using a dictionary. But of course, a dictionary adds more space, but I guess that's part of the discussion. If you used a dictionary here and did what you did in the last problem by just keeping track of them as you're going along, adding them, and then you would, the moment you find 2 in your dictionary, then you return true. Right? Just like you did in the last problem.
Yeah.
You keep a count. If count of the num equals 2, then return true, right?
Yeah, but you don't need a dictionary for that here, right? So you at least, sorry, a set would do it, right?
Yeah, well, I guess you're looking for a count of 2. I don't know how a set gives you a count of 2.
So you're not necessarily looking for count of 2, you're just looking for existence or not.
Yeah, okay, so if it's in the set, sure. So that's
Yeah.
at least that's O of n, right?
Mm-hmm.
Yeah.
Yeah, exactly. So that is the most efficient way to do it. But as you mentioned, in that case, the memory goes up. So if memory usage is the thing, we are not adding any memory, for example, in this solution. So you should see the trade-off and see which one is more important based on the given context. But yeah, usually in interviews you have to discuss these options, and then you'll come up with a solution based on what is expected. But let's actually keep that for data structural algorithms for now. Yeah, cool. Thank you, Brian. All right, so let's go to the next one. All right, so intersection of two sorted arrays. So for this question, actually, we have also two solutions. So let's see how many solutions are left. Okay. So to make sure we're on time, I'm gonna go over one, and I'm gonna share the second one with you. So the second one is you completely know all the syntax. You should be able to do it without using any Python built-in functions or any sets. The solution that I'm going to show you first is based on sets. Okay, so first let's see what's the question. The question is, given two integer arrays sorted in non-decreasing order, find the intersection of both the arrays. Okay, so we have two lists, and the intersection without any copies is 2 and 7, because here we have both 2 and 7, and we have those two numbers again here. So without any copies, we're going to get this list, right? Example 2, there are no intersections. And when there's no intersection, we just return -1. So it says intersection should be free of duplicates and sorted in ascending order. And then if there is no element common in both the arrays, return -1, right? Okay, so let's see how the solution looks like with sets, but then there's another way to do it in a bit more, I would say, writing everything from scratch. But I will give you the idea, but I'll let you think about it on your own as an exercise. So the solution to this with sets would be, okay, so we have two lists. We're gonna convert them to sets, and then we're gonna find their intersection, and then we're gonna sort it, and we're gonna convert it back to list, right? So this is how we can do that. So if you have list 1 and list 2 or numbers, we can get set 1 is typecasting numbers 1 into a set, numbers 1, and same thing with numbers 2. Okay. Now, the intersection of these two sets we can find using set intersection, which is, let's call it, I don't know, intersection is set 1 intersection set 2, right? And then after we have the intersection, we're going to get the sorted list. So what we can do is we can actually use that sorted function I just told you about and typecast this intersection as a list, right? And this is going to return a sorted, basically, list based on all those elements, and then we can just return that, right? So let's call that the final result, right? So we can call it result. So the only option that we have to be aware of is when result is empty. So if there's anything in result, we can just return that, return result. Otherwise, we have to return -1 because it could be empty. And if it's empty, we are instructed to return -1. Okay. All right. So let's see. This is the right way, right? So result. Yeah, so it should be fine. I'm thinking maybe you can write this in a simpler way. I think you can write this in one line using return 1 minus Boolean of result times, yeah, if results exist, yeah, you can just do something like this. So Boolean, so I mean, I'm writing this because this is an overall idea that I wanted to show you, if I remember correctly, but yeah, I think this looks something like this. So what's happening here is the Boolean of result is either 0 or 1, right? Or you can do integer, integer of result. But is result is a list. So yeah, you can use both integer or bool. So typecasting it as bool gives you a true, and then you can, if that is a true, then this becomes a 0. So this part becomes a 0. and you get the result. But if this is a false, then this will become a 0 and this will become a 1. So you'll get -1 in a list here. So yeah, I mean, whenever you have such conditioning, like if result else, you can do that in one single line, but yeah, that doesn't really, just wanted to let you know. Okay, so that was the first one. Any questions on this solution before I give you a hint on the second one? So I see there's this question. Is there a difference between result being null versus empty? No, actually. So at least for this case, no. When I say null, so null, you can relate it to all these data types, right? So if an integer is 0, you could say it's null. If a list is empty, or you know, any other, if you don't have any values in a container, you can say it's null. But then none is different. None is actually a type in Python. None type is defined in Python. And none goes side by side with numpy dot not a number, which you can use both for missing values in a table. But that's a topic for last week in the class. So this last one is using while loops. And you know, basically one pass through these two lists. So it's not an you know, complicated idea. Just writing it is a little bit messy. So you should look at these lists. Use a while loop and you know, go through these lists one by one, and then when you see a common item, then you add that to your intersection, and then go all the way, because they're both sorted, right? So they're two sorted arrays. After you find that intersection, you jump all the way to the next element, which is not the same, right? So it's not, it's a bigger element. It's a larger one. So yeah, and then here we find 6, 7, 6 goes to the right, becomes 7. We see 2 7s, and then they both go all the way to the end, but now the list is over. So you get your intersection list, right? So that's the main idea. You know everything to write the solution, but you know, getting the final answers could be a little bit tricky. So I'll let you work on this as an exercise. Okay, so any questions on this problem before we go to the next one? I don't see any questions. So let's go to the next problem. Single number. All right, so single number is asking us that, you know, if you're given a list of numbers in which each number appears exactly twice, except one number that appears only once, find the number that appears at least once. And then there's a hint in this parenthesis, not a hint, trying to make the question more challenging. Try solving this in linear time complexity without using any extra space. We shouldn't really worry about that, but I actually show you how to do it. It's something we haven't learned about. So I'm gonna give you a hint, and then you can think about it. It's a new tool in Python. It's good to know, but out of the scope. So our solution to these kind of problems, so let's say we have this list of numbers, right? We know how to count these numbers efficiently now. We can use a dictionary, right? And then get the count of each of these items. And then when we have a dictionary, we know the counts, whichever is 1, then that will be our single number, right? So let's actually create that dictionary together once again. So I'm gonna get counts, and for num in, this time its name is array, or num in array. So let's do that cool fancy thing that was proposed by one of the learners. So count at num is count, or counts that get num default value 0 plus 1, right? So this would give us an increment to the value. And after this for loop, what happens is that now we have all the key values. Now I'm going to pass through this dictionary once again, look at the key and values. If I find a value equal to 1, I'm going to return the key, right? So for key value in counts.items, you remember that counts.items method would return a list of tuples, and each tuple had 2 elements, key and value, right? It will return all the items. Oops. So now for each of these key value pairs, if the value is equal to 1, that is our single number, right? Then we can return its key, right? So we know that there's only one number with the value of 1, so that will be our final answer. It doesn't say that it couldn't exist, so that would be it. All right, so this is our first solution, which is solution 1, dictionary. So before I go to the next one, any questions? So I see there's a hand raised. Vijita, please go ahead.
So how I attempted and did this one was using sets. So basically, again, using the same idea, check for existence. So every time I pass through the list in each element, I put it in the set, and if if the next element exists in the set, in the same iteration remove it from the set basically, and at the end of the iteration there will be only one element left in the set, which is a single one, and you just pop and return that.
Yeah, that's a
So
great idea. You can do that.
okay, that would be linear too, correct? Because we're just passing the list once. I mean, the set is again like dictionary, additional memory, but those popping addition and the removal of the elements shouldn't be too much of time complexity, right?
No. Yeah. So that's constant time, basically. Yeah. No, perfect. Yeah. So that's what you can do. Actually, you can use sets, and each time you see an element, if it doesn't exist, you add it. If it already exists, you remove it, right? At the end of this process, you're gonna get one number which is not removed, and that will be your single number. That's a perfect solution. Yeah, thanks for sharing.
Thank you.
Yeah, cool. So that was one solution. So this dictionary one is another one. So the other solution, actually, I also want to tell you about is actually using pure math, and this is an optional solution, but it's fun. I wanted to share with you. So what happens if, so let's say we have this list. So what happens if, for this example, I find the sum? So sum of all the elements is what? Is 2 number. So we have 2 number of 2's, right? 2 times 2 plus we have 2 number of 1's. 2 times 1. Let me put parentheses to make sure we're not confused between these. And then we have a 5, right? Okay. So this sum, basically, if there was another 5, then this sum will actually give us twice the number of sum of unique values, right? So for example, if I find the set of this thing, then the set sum, right? So if we find the set, then the duplicates will remove, right? So the sum of that set would be 2 plus 1 plus 5, right? Now, if there was no single number, if you had another one of these, then this would become 2 times 2, right? So 2 times 2, 2 times 1, and 2 times 5. So if I basically get this sum and multiply it by 2, then that will be the same, right? So now, if you look at these two items, so this is actually 2 times that set sum. If I subtract this number from this number, all these things which are duplicated, they will all go away, but I only get one single number, which is my answer. Okay. So now how can I implement this? I can say, so this first one is basically the sum, right? So this is the sum of all elements in my array, right? And this second one is 2 times the sum of the set of array, right? So the set of if we convert it to a set, duplicates will go away. We multiply it by 2, it will give us this one. But we know that this one minus this one will give us the single number. So if I put this here, this thing minus this thing, this should give us the single number, right? So we can just return that. Okay. So that's just a math trick where you have duplicates of all these things. How can I make it complete and have duplicates of everything? And now what's that missing piece? That missing piece would be the sum of what I have already and the sum of that completed version. So if I find a subtraction between the two, that will give me that missing piece, right? So this is the idea. All right, so the last solution, which I'm not going to go over, but I'm going to let you think about it, is the XOR operation. So the XOR operation is basically for binary numbers to actually compare the digits 0 and 1, and then do all these calculations and give you another number in binary, its binary version. So I'm not going to go into the detail of that, but what we know about XOR is these things. So I have A XOR B is B XOR A, right? So I remember, I think this was called commutative property. So A XOR B is B XOR A, and this is how we show XOR by this hat symbol. The other thing is A XOR 0 is A, and this A can be any number, and this B can be any number. And then the last thing is A XOR itself will give you 0, would null out its own effect. Okay. So see if you can actually find a solution to this problem using XOR. Should be straightforward. So it will give you a 1 pass through and 0 additional memory because you don't need to really define any new container or any new variable, and you're passing through this data only once. So that will give you that solution with linear time complexity and no extra space. Okay, so this is out of scope. You don't need to know about it, but I'm just showing you this for those of you who are interested. Just give it a try. So the right answer, I mean, the suitable answer for this class is this one and the one that Vijita mentioned with the sets. So these two solutions are the right ones for this class. But just wanted to also give you hints on the other two for those of you who are interested. Any questions? All right, so if there are no questions, let's go to the next one. All right. So the next question is squares of a sorted array. So given an array of numbers sorted in increasing order, generate another array containing the square of all elements in a given array sorted in increasing order. So the question looks pretty straightforward, right? So we are given a list and we're going to return the squares of this list. And we had the map function which would exactly do this for us, right? Now, we know that from what we learned, we can actually do this in the given order. So if we're given 1, 2, 3, 4, we can actually get this output, which is 1, 4, 9, 16, which is the square of each of these numbers. And that's fine. We know how to do that. But now, the trick of this problem is when we have negative numbers, right? So when we have negative numbers, then the square root of -9 becomes a positive number, which is 81. And the square root of 7, which is 49, is less than that. So basically, if we find the square of -9, then it should go to the right end of this array, which would change the order of the original array given, right? So that's the tricky part. When we have negative numbers, then we have to make sure that we are going with the right order, because now the map or other ways that we know, that's not going to work. Okay. So what is the easy way to solve this? So we know how to find the squares of these numbers. We just need to sort them, right? So the easy way, which is our solution 1, is sort, right? So using sort. So what we're going to do is we're going to go pass through this, and then after we find the squares, we're just going to sort the final array. And this should be pretty straightforward. We have seen all the ideas. So in range length of numbers, we are gonna we can change the original list, or we can create a new list. So I'm gonna change the original one for now, but doesn't really matter. So numbers would be numbers at I to the power of 2, right? So we're gonna find the square of each value. And then after we're out of this for loop, we can just simply sort this array and return it, right? So this is the easy solution, which is not very efficient because we passed through this list once, and then we are sorting it, which is an n log n on top of that. So from time complexity viewpoint, this is not very efficient. Now the question is there any way that we can do this in a linear way, in a more efficient way, and not use any sorting as such? The answer is yes. And I'm going to go over that solution. It's a little bit tricky, but I think the idea is nice. Yeah, so I think we have enough time, so I'm just going to go over that. Any questions about solution 1? So if there are no solutions, let's go to the next one. So the next one, the idea is 2 pointers. So usually the idea of 2 pointers comes up with a linear solution, which is nice. Now, how does that work is, let me copy this one here. This is an interesting idea, which could be helpful in many other use cases. But the idea here is, how can we understand the order? Because this is already sorted. So the question says we are given a square of sorted arrays, right? So it's already sorted, but how can we understand which one of these goes last, right? So what happens after this negative number is squared? So the answer is that if you have 2 pointers which are looking at, so let's call them left and right again, which are looking at these two. Now, at that point, you can find the squares of these 2 values and check to see which one is larger. So for the larger number, you place that at the end and then move that pointer to the next, and then you keep doing that, right? So for example, if my last, so this is my, let's say, result, right? So I'm looking at these 2 numbers, -9 and 7. So what is the square root of -9 is 81. Square root of 7 is 49, right? 81 is larger, so I put 81 at the end. Now I go backwards, right? So this, because we have already seen this, L goes to the right. Now the square root of -5 is 25. Square root of 7 is 49. 49 is larger, so we put 49 next. I mean 1 to the last. And then this goes 1 to the left. Between -5 and 3, this one wins because it's 25 is larger than 9. So it goes to the beginning. Between these 2, 3 wins. It will be a 9. And then between these 2, L or left index wins because it has a 4. And then it goes to the right. But now in this case, we need to also check the case where we have equality, because the last element is also important for us, which is a 0. Okay. So this is the trick for this one, which we're gonna basically use to solve this problem. Okay, so just to go over the solution very quickly, L and R are 0 and length of numbers -1. And then what I'm going to do is I'm going to actually create a template for this, right? So I'm going to put some zeros side by side and then start from the last element. You can also use insert that we learned in lists. Both work fine. But what I'm going to do is I'm going to create my result, and I'm going to use that duplication operator for lists to create these zeros side by side. I'm actually going to multiply it by length of numbers. Okay, so this is going to give me something like this: 0, 0, 0, ... all the way to the end. Okay, so this is kind of a placeholder for me to insert these numbers at the right spot. Now, actually, I also need to, in this case, I also need to see where I should put these things, right? So I also need a pointer to follow the right, the right index here. So I'm gonna call that, let's call that P, which should start from the end, which is length of numbers -1. Okay. So right now, if this is my result, so my result currently is all zeros, then the pointer or P is referring to this last one. Okay, so it starts from the last and we take it 1 to the left each time. Okay, so this is our initialization. Now we go into this while loop while left is less than or equal r, because we want to also check the last element in the order. So if that's the case, then we are going to find the squares of those values, numbers at left squared. So let's call that left square. I call this L square, and same thing with R square. I'm going to have R to the power of 2, right? Now I'm going to compare these two and see which one is larger, which one is smaller. For the larger one, I put it at this P index in that list, and then move P one to the left. And then if I need to move L and R around, I will do that, right? So if L square is less than R square, then R square is larger. So what happens is numbers, or sorry, results at R square, results at P becomes R square, right? So the pointer is now pointing to the end, and my larger value would go at that pointer. And what it means is that now I have to go one to the left from right, right? So from this right index, I go one to the left. Now, the next condition is L if L squared is greater than R squared. So if that's the case, then at that index, which P is pointing to, I'm going to set it equal to L squared, because that's our winner. That's the square of that value is the winner. And now left goes one to the right. Okay. And then if, I mean, either of these will happen, even if they're equal, which this should happen. So basically, actually, I could put a else here instead, right? So I didn't really need to do elif. Okay, so the only thing that remains is that we make sure this P is also moving. So it starts from the end, but we need to make sure that it's also moving, right? And then at the end, we just need to return this result, right? So we just need to return our final result. Okay. All right, so this should give us the right answer. Any questions on this one? No questions? All right. So if there are no questions, then let's go. We have two more problems. I think we have enough time for me to go over most of the solutions that I have here. Let's see. Yeah, I guess I can cover most of the solutions. So there's only one here which I think it may be a little bit out of scope, but let's go over the problem. So the next question is maximum sum of subarray given a list of integers. Find the sum of a non-empty subarray that has the largest sum. So if you look at this list, what is the subarray that gives us the largest sum? So when we say subarray, first of all, it's a subarray. It's an array composed of a contiguous block of the original array's elements. So by contiguous, it means consecutive elements. So you cannot break. For example, 2, 3, 4 is not a subarray because there's a break in between. 2, -6, 3 is a subarray, right? Now find a subarray which gives us the highest sum. Okay. Now the question is, how can we find it? So here 2 by itself is a subarray, so it gives us a 2. 2 and -6 gives us a -4, so it's even lower than 2 alone. So 2, -6, 3 gives us a -1, which is better, but still 2 on its own is better, and 3 on its own is even better. So 4 on its own has the highest sum if we go with single values, but then we can go with this 3 and 4, right? Which is basically sandwiched between these negative numbers. So this is going to give us the highest subarray in this case, which is a 7. Okay. Now for the next problem, next example, I have some negative numbers. And each time you add a negative, it's getting worse, right? So I only pick the largest number by itself. That will be my highest sum. So I don't let the other negative numbers bring that number even further down. Okay. So actually the solution I'm going to show you here is basically the normal, I would say, brute force solution. But there's also a very smart way to solve this, which is also pretty challenging. I would say it's not easy to come up with in an interview or in another setting. So it's called, the algorithm is actually has a name. It's Cadon's algorithm. I'm going to share that with you on the notebook. Please go over that on your own, think about it, see how it works. But we will not go over that in the class because it's out of the scope, but you know all the syntax. There's nothing, I mean, I think maybe there's only one thing, so which I'm going to show you now. So if you want to come up with a really, really small number, which is smaller than any other number, or basically -infinity, you can use math.inf, which gives you infinity, and you can just put a negative at the beginning, which gives you a very, very small number. If you want to initialize with that, then you can do that, or you can just put a really small number. You can take a look at what are the limits, elements of the list 10 to the 4. So probably 10 to the power of 5 is lower than any number you see on this list. Anyways, so we can use this as a very small number, and that's enough for you to understand both solutions. So the way I'm going to solve this one is I'm going to find all combinations of basically all subarrays and then see what's the sum of each. If it was higher than what I've already seen, I would update my current observation, right? So that's how I'm going to solve this one. But as you may guess, this is pretty inefficient because I'm again using two a nested for loop, so 2 for loops, which is not very efficient. So let's actually define this maximum subarray, max subarray, which is what I'm trying to return at the end. But I start from a very, very small number so that whatever I find is 100% more than this. So this will be updated to that value. Even if you find a negative number, that's still larger than this negative infinity. So as long as the array is not empty, which is not, because it says it at least has one length of 1, then we are good to go. So I'm going to go in a for loop for I in range of length of numbers. So I'm going to get the current subarray. So what is my current subarray? So let's start with 0, right? And then now I'm going to start looking into the second dimensions or the second index. So for J in range, I'm going to begin with I, because each one of these elements can also be a subarray on its own, right? So starting with I and then going all the way to the end of this list, length of numbers. Okay, now let's say I is here. So if I copy this one. So let's say I is here and J is here, right? I'm going to check to see if this range of values, the sum is greater than what I've already seen or not. Okay. So you can keep adding this to your current subarray. The other way you could actually solve this is to find the sum of this slice of our list. Okay. So I keep adding that here, but you can also try that slicing on your own. So what I'm going to do is I'm going to have current subarray and add the numbers at that index to it. So I have numbers at J. Okay. And then what we have currently is the sum of our current subarray, which we're going to check to see if it's larger than the maximum subarray. So I'm going to then update the maximum subarray to make sure that it's the maximum of the two current subarray. Okay. Okay, so if we just keep on going on and on in these two for loops, then we're going to get the maximum subarray. Right, so what happens here is we are seeing all combinations. So J starts from here, from I, and goes all the way. So each time it gets this number, like it gets 2, we check to see if 2 is already larger. And then it goes to the next one. It checks 2 plus -6, which gives us -4. And this update doesn't happen. And it goes all the way checking the cumulative sum as it moves forward, right? So when I gets to this location, and J starts from the same spot, and J goes here, then the sum of these two will become 7, and nothing else will beat that, right? So 7 becomes our maximum subarray sum. Okay. All right, so that was the first solution, and the second one is called Kadan's algorithm, which I'll let you think about it and then go over the solution and then see if you can figure it out. I would say the best way to, I mean, it's not a large solution, it's like 4 or 5 lines, but go over an example and try to see what happens at each step. Is there any question on this solution before we go to the last problem? I see there's a hand raised. Wichita, please go ahead.
So, I mean, we have to return here the sum, the maximum, which is 7. If let's say we had to return the position, the index, index 2 and 3 in this case, which is the subarray that has a maximum sum, then then we could in that for loop also just store the indices, and then every time we do a max and return at the outside of the loop. Is that what we do? Like if we have to return the index instead of just the maximum.
Yeah. So in that case, we also need to keep a record of the indexes, right? So maybe what we can do is we can have, in that case, we can have an if, and if, so maybe we can do this. Maybe we can comment this out and write this with our own conditional statement. So if the current subarray is greater than or equal the maximum subarray, right? Then replace the maximum subarray value,
Yeah, that
right?
works. And then
And
for the indexes, yeah, we can replace indexes as well with the
exactly. And then we can say maximum index would be INJ,
no,
right?
yeah,
Then we can return that maximum
yeah,
index.
yeah. Thank you.
Any other questions? Okay, so let's go over the last one to make sure we're almost at time. I mean, we are at time, but let's go over the last one to make sure it's not going to get too much extended. Okay, so the last question is find the winner of election, given list of votes containing names of candidates in an election. Find which candidate received maximum number of votes. If two or more candidates got the same number of votes, return the lexicographically smaller name. So here we have 4 votes. Sam has 2. John and Jamie have 1. Sam is the winner. Okay. Here we have 2 votes for Sam, 2 votes for John. But then if there's a tie, we will look at the the alphabets, the beginning of these names, and then because J goes before S, John is the winner. Okay, so length of votes is less than this number. Length of each vote, the words is less than this number. Number of characters combined. So these are some constraints to make sure that this is not going to blow up. Okay, so we already know how to do this with dictionaries, right? So if I want to show you, so let's say solution 1, use a dictionary, right? So we already know how to use a dictionary here, right? So we can use a dictionary to count the number of votes. And by count, I mean we have these names as the keys of the dictionary, and number of times they occur in this dictionary. But basically in these votes will be the value corresponding to that key. And then we go through these values or the items of the dictionary for any value which is the maximum. We can find the maximum of values, right? We have the dot values method, which gives us the values, and we can find the maximum. Whenever we find the maximum, then we basically know which key we have to return because that's the winner. And then we can return the maximum winner to make sure that it's lexicographically the highest, right? So I let you go over that solution on your own because you already know everything, all the techniques and details of that solution. What I'm going to actually go over in this class is using counter, right? So actually, I wanted to show you what counter is for this class to make sure. I think I mentioned it very briefly in the Sunday class, but counter is actually, so this capability of counting elements in a dictionary is so powerful and so useful in different applications that there's actually a module defined in Python for that. So if you want to use it, you can import it from selections. You can import counter, and it starts with a capital C. It's an uppercase letter in the beginning. So what it does, it actually creates a dictionary for you based on all the counts. So if I write vote count is counter of votes, so what this line does, this part on the right, this will, from this list of votes, it will create a dictionary for you. And the keys of the dictionary would be these names unique list of these names, and then the value of those keys will be the number of times they have repeated in this list. And so this is going to give us what we're looking for in this previous solution as well. Now we have this dictionary, we have these counts, and we have the counts as their values. Now what we need to do is to find the maximum, right? So the max votes, let's call it, is the maximum of vote count dot values, right? So we find the maximum number of votes using the dot values method, and we get the maximum of that, right? Now I'm gonna actually use the list comprehension trick. It's gonna make my solution a bit more complicated, but just intentionally want to show you how we can use all these techniques together in one place to make our solution shorter. So now I'm gonna find all the candidates with maximum votes, because we can have multiple of them, right? So candidates with max votes, let's call it this way. Okay, so hopefully I have enough space here. Let me make it a little bit more. Okay, so I'm going to use list comprehension. I'm going to create a list from all the votes who got a value equal to this max votes. Okay, so I'm going to write, I'm going to get all the candidates for candidate and count, right? So I'm going to get both candidates and their count in vote count.items. So this was our dictionary, right? So this vote count is our dictionary, and I'm going to search through all the candidates and counts, the pairs in that dictionary, and with a condition, and the condition is that the count should be equivalent to that maximum number of votes. Okay. If count is equal to max votes. Okay. So this list comprehension that I write here for candidates for these two as pairs which are given in this list of items, if count is equal to the count to the maximum votes that we found here. Okay. If that's the case, then now we have a list of all the candidates which are potentially winners, but we want to get the one with the lexicographically lower name, so we can return the minimum of this list. Okay. So that is our solution in 4 lines. So we use a counter to get a a dictionary which counts the number of votes, and then we are gonna basically get the maximum number of votes that candidates can get, and there could be multiple candidates with that number of votes. So that's what we are doing on line 34. So we are finding all we are finding all candidates which have a count equivalent to the maximum counts in this list comprehension. And then we're going to return the minimum of those candidates. And the minimum will go over the alphabets one by one, and then try to find the one which is lexicographically smaller name. Okay. All right. So that brings us to the end of this question list. I'm gonna see if there are any questions now. I'm gonna stick around for a few more minutes, but otherwise we're done with all the questions. So if you need to drop, feel free to do so. And thank you all for joining. Otherwise, I'll be here to answer questions. All right, so I see there's a hand raised. Vijita, please go ahead.
So I have a question about, about using functional programming and like using Python functions, lambda, map, reduce, and list comprehensions. This is a little bit of a new programming style, writing compact code with all of these new constructs in Python. And I find it difficult to do, a little bit hard to, I was practicing using function map, and that's getting settled, but list comprehension sometimes is really too much to think this way. How much practice, like as the course goes along, with the practice problems, will we be able to practice enough that it will be relevant for the course, or we need to put in extra effort? Because I come from C++ background and and Java background, so this is pretty new for me.
So I have a way that I think should be very helpful, at least these days with ChatGPT and all the tools that we have. So this is what I would do. I would say, I mean, you don't have to write the list comprehension. You can always come up with some solution without list comprehension. But if you want to get very, very comfortable with the list comprehension, writing a list comprehension, I would say don't rely on the practice problems really in your in any practice set or any project anywhere. When you see wherever you see a list is being formed, so whether it's through a for loop or any way a list is formed, think of how you can do that with the list comprehension, right? So try to see if you can come up with a way to create that list with list comprehension and spend a few minutes on it. Then you can ask some of these language models to create a list comprehension for me for this part of the code. You can copy paste that code, and then you actually see how it looks like, the list comprehension. So that's what these LLM models are really, really good at. And then first you have to try, but then you get the right answer, and then check what you have been missing. And then after 4 or 5 times, I promise you're gonna get there. You'll get pretty comfortable with writing a list comprehension.
Okay, thank you.
But that's what I would do these days. Yeah.
Okay.
Thanks. Yeah, thank you for the question. Any other questions? There's nothing on the chat and Q&A. And I don't see any hands raised. Let's give it a few more seconds. But anyways, thank you all for joining. Hopefully the class was helpful for you. And so I'm going to see you on Sunday for the 3rd week. And we're going to cover object-oriented programming together. And then after that, there will be a few more tools in Python, which would then lead to our last class on Python for machine learning. So I see there's a comment here. I'll be in a flight, not home Sunday until probably 2:30. Oh, 2 hours of the class. Do I need to let you all know ahead of time? Not really. So the classes are all recorded, and attendance is optional. It's not mandatory. So, just feel free to join in whenever you can or drop at any point. And then catch up with the recording after the class. All right, so if there are no other questions, thank you all again, and see you on Sunday. All right, thank you all.